All right. Well, I am John Jordan. I'll be speaking on the time I actually finished the 100 Days of Code Challenge. A little bit about me. I started out in healthcare. Currently, though, a project manager for a utility construction company, and I started coding mainly in the fall of 2018. So this is kind of my journey from that time. I kind of put it as round one, 100 Days of Code. Publicly committed on October 9th, 2018. I was following the freeCodeCamp responsive web design track, and I also picked up a Udemy web development bootcamp course because it said if you buy this course, you'll know everything you need to be a web developer, and it's only $9.99, so I couldn't resist. So I picked that up just to hedge my bets. And I also went to my first Techlahoma meetup, and it was a job fair, October 29th, 2018. So how I kind of started was I sped through the HTML, CSS sections. The tutorial would kind of demonstrate something, then I would do the same, and didn't have any problems with that. I'm pretty good at following instructions. But when I got to the final projects, I got a little overwhelmed with them. It doesn't, tell you do this and that they give you the project and you kind of have to organize your own code and piece that all together. And so that was a little bit of a struggle for me. So I kind of tried my best to work through the 5 different projects, and I didn't manage to complete them. So I just kind of jumped over to the JavaScript section and struggled there as well, and ended up, I guess, day 49 as it shows there. I stopped my coding journey, kind of got frustrated. So that was my round one. It wasn't till the next year, May 1st, 2019, I started second round of 100 Days of Code. I said, all I can say to procrastination is not today. And that was kind of funny in hindsight because it was about another month and a half before I actually got back on Twitter to document anything. And kind of fumbled my way through a little bit longer before stopping again in July of that summer. So round 2 wasn't near as successful as even my first round, but here we are at round 3, another common time for resolutions. The beginning of January, I decided I was going to take another stab at this, and so I started off again and started back with the freeCodeCamp, reviewing the past material. Had to do that because it'd been 6 months before I'd done anything, and so if you don't use it, you lose it kind of mentality. I didn't remember much of a lot of the syntax and how to do anything. So I went back and reviewed and got to the projects again, and this time I actually succeeded. I finally completed the responsive web design certificate. I'm still not very happy with the way they look, but I did meet all the requirements, so I do have the certificate to prove that. And from that point, I continued on to the JavaScript, where I kind of jumped back and forth between the freeCodeCamp and the Udemy course that I had. Whenever I'd get to a sticking point, I'd hop over to the other curriculum and go as far as I could. And when I struggled, then I'd go back to the other one and kind of went back and forth in that manner. So didn't get too far on it. And then I eventually stopped counting the days at some point. I continued to code off and on, but the turning point was kind of when I got involved more with the freeCodeCamp Oklahoma group, which brings me to the round 4. It started off actually with a weekly progress group. Some of us kind of made this group on Slack, and it was a way to hold each other accountable, to check in and kind of report what we was working on that week and what our goals were for the week. And after a little while, several of us had actually started doing the 100 Days of Code. So I jumped on board and officially started my round 4 on August 7th, and working my way through that. This time I succeeded in completing the 100 days. So it was a pretty good feeling. My version was not as strict as the official 100 days. I should probably mention that. But I needed a format that I could follow, that I could be consistent with, and not feel like if I, missed one of the parameters that it set forth that I was failing and might as well stop again. So I found a format that worked for me, where I could still have a day off or miss and then come back and pick up where I left off and continue on. So some of the things that I learned going through this process, through the 4 rounds, or actually through this 100 days, I started with the JavaScript. I used the Odin project, which is a kind of a compilation of resources that you can use to learn some front-end development. But I quickly moved on to Python after a few weeks. I tried this out and it really clicked with my brain a little bit more than JavaScript was. So I ended up continuing the rest of the 100 Days of Code Challenge doing Python and some of the related things with that, including Django and Tk-enter. Django, I went through the Django Girls curriculum, and I looked at a course on the lynda.com website about Tk-enter and was able to make a small little user interface for an app that I developed with Python. I also participated in the Hacktoberfest this year and completed the pull request required. Still waiting on my t-shirt, but I'm sure it'll eventually make it my way. As I mentioned, I did build several small little apps, little games or utility apps. It was fun to make. And I completed my first API call using the Google Books API. I was able to gather the information, book summaries, titles, authors, and things for a small app I was playing with. And finally learn more about networking and how important it is to be networking, that it's never too early, even when you're just starting coding, to kind of get your name out there and let others know who you are, what you're working on, what you're interested in. So that was another thing that I thought was beneficial in my 100 days that I learned. Some of the takeaways I would say from going through this is that consistency is key. A quote from James Clear I liked was, "Most people need consistency more than intensity. Intensity makes a good story, but consistency makes progress." And I think I did have some intensity in my previous attempts, but the consistency was not there. I would lose focus and gradually was not making progress during those attempts. And something that helped me maintain that consistency is finding a source of support. For me, it was Techlahoma's, the Slack channel, the support group that I was in. I could come in there and kind of, I knew somebody was going to ask how I was doing, what I was working on, what goals I was working on for the week, which kind of helped me maintain some accountability there. It could be Twitter, LinkedIn, Facebook, whatever you're most comfortable with, that you have a group of people that knows that can support you and check in on you and hold you accountable to staying on task and making progress each time. And finally, to have fun with it. If you're not having fun, then you're a lot more likely to give up or to step away to some other venture. But it doesn't have to be, really upsetting, frustrating, where you're throwing things. Some days may be more frustrating than others as you're learning to code, but try to enjoy the process as much as you can. Find things that interest you. If you're beginning coding and you're learning a language and it's not going the way you thought it would, try another language. Jump over to something that you know that is interesting to you, that you can spend some time learning and enjoying the process. Hopefully you're spend more time on the enjoying side than the frustrating side in these two depictions. But that was kind of my journey where I'm at. I'm continuing to code, not under the following days thing, but continuing to make progress and consistently be in my computer working on my skills at the moment. So that's all I got for you.
Thank you, John, for sharing your code journey with us. I do want to mention, like John said, we are on Slack. If you have any questions, you can always reach people on Slack. So slack.techlahoma.org is a great resource for everybody. Up next, we have Kendall Werts, and she's going to talk about how you can get a job when you may not have that much experience. Kendall, take it away.
Hello. Sharing. Here we go. Nope, not that one. All right, so my talk is called How to Get a Job When You Don't Have Experience. Yeah, my name is Kendall. I'm married with 2 kids. I am the president of Techlahoma. I was a chemical engineer for 10 years, and I'm now a full stack developer with Bayer Crop Science. I also like to bake and make beer. So how I transitioned to a tech career. I always liked programming. I had actually, when I entered college, I had told everyone I was going to be a computer science major, but I got a little scared off from it. One of the courses you had to take was an electrical engineering course in order to get a computer science degree for some reason, and I did not like electricity and magnetism in physics, so I was not excited about this electrical engineering course. So instead of that, I took a senior level AI course as a sophomore, and that was a terrible idea, and I did not end up completing that degree. So I became a chemical engineer, and I was doing that for 10 years until about a year and a half ago. I got sick of travel and layoffs and all kinds of junk, and decided to try to become a software developer. So I was laid off in June of 2019 because I refused to take a job that required 70% travel. So that doesn't sound fun. So I decided to start developing, and I had developed, I had done some programming, mostly for fun. And a little bit, I had a job where I wrote engineering code for like 20% of the time for a couple of years. So I had been developing, but I was nowhere near like professional level. I did not really know how to use version control, things like this. So I started an LLC in June of 2019 so that I could work on some projects. And then in November, I applied to be an outreach intern. An outreach internship is for underrepresented groups in tech. And basically you work on you get paid a little to work on an open source project for about 3 months. And you get a mentor and everything. So that's a really cool opportunity. And then I got a job 2 weeks before the pandemic hit, amazingly enough. So that sounds easy, right? So you might have heard my story and said, oh, well, that doesn't apply to me. Kendall, I'm not an engineer. I can't make an LLC. I'm not an underrepresented group. Yeah, I mean, my story, everyone's going to be different. And everyone's entrance into the industry is going to be a little different. So I try and take a few topics from my story and to sort of help guide other people. There are some things that you can take from my story, is what I'm saying, to help you try and find a job. So the three main things I talk about are you have to get connections, you have to do some work, and you have to apply an interview. So the get connections part is probably the most important part. It is it's who you know. It's who you know. It's pretty much just who you know. But Kendall, is it really who you know? Well, I got my internship through someone I know. I got my job through someone I know. And I got 80% of my interviews through people that I met at Tulsa Web Devs meetups. So yeah, it really helps. I mean, you can send out 1,000 resumes and maybe you'll get 10 interviews and maybe you'll get one job from that. But the chances of you landing a job are much, much, much higher if you're talking to people that you know about the opportunities that they have at their companies, or about the opportunities that they've heard about through other people. Like it's very important who you know. So how do you build a network? How do you make connections? So obviously user groups, conferences, and networking events are all very good for this. User groups, these things are also kind of hard to do right now since we're in the middle of a pandemic. But Techlahoma has lots of virtual user groups. So I think those are still useful and still useful for networking. You can also try the brute force method, is what I like to call it. I learned about this a couple weeks ago. One of the ladies at She Codes did a presentation on how she landed her job as a data scientist. So she broke into the data science area, and the way that she started networking was she started connecting with people on LinkedIn, and then she would message them and set up a virtual call with them. She did this during the pandemic. So in, I think it was like 3 months, she contacted lots of people on LinkedIn, met up with them, had virtual calls with them, talked to them about, what's your job like? What is the industry like? How did you get your job? How, what do you work on? Like, she was very interested in the industry as a whole, and she used that to connect with these people, and that's how she eventually got a job. And if you do that, you're going to be at the top of everyone's mind, right? You're going to remember that woman who reached out to you on LinkedIn and was really, really into data science and really wanted a job. So so that worked really, really well for her. I thought it was really cool. And then the last thing, Twitter is also a good place to make connections. So you can talk about what you're working on Twitter. You can ask questions on Twitter. There's a huge tech community on Twitter. It's big. And then the last one is give talks. So the ones I've started, I'm going to talk about a little bit more. But you might say, Kendall, I've been to user groups and conferences, and I don't understand anything that they're talking about. Yeah, that's pretty normal. I doubt anyone at user groups and conferences understands everything that everyone is talking about, because then they wouldn't necessarily need to go, at least for the educational aspect. I think that's really common, and I think as a entry level or junior level developer, it's still really, really important that you go to these things, because even if you don't understand what they're talking about, you pick up jargon, you pick up vocabulary, like you have an idea what Kubernetes is. Maybe you have never used Kubernetes before. I certainly haven't, but you have an idea what it is. And if it's brought up in conversation during an interview or whenever, you don't have to be like, well, I don't know what that is. You can talk about, you can talk about it in with some context, and that'll really help. And I like to tell the story of one of my interview questions. Someone asked me about the difference between a SQL and a NoSQL database. And I had never used a NoSQL database. And the only SQL databases I'd used were just sort of set up for me, and I didn't know much about them. But I had heard someone talking about it at a user group. And I remember what they said. And so I basically just said the same thing. I said, oh, well, NoSQL databases don't scale great, and like a Postgres type database is good because it's a hybrid. And I didn't fully understand what I was saying, but it really helped in the interview, and it worked. So, all right. Next is give talks. This makes people very uncomfortable. I get it. But even like a 5-minute lightning talk can be so helpful. I got my first interviews after I did a lightning talk at Tulsa Web Devs, and I said at the end of it, I actually forgot, and I walked down off the stage, and then I ran back up real quick to the microphone, and I said, oh, by the way, and I'm looking for a job. So I got my first interviews after that, and then you don't have to talk. So when you give a talk, you don't have to talk about something brand new or something breakthrough. You can talk about anything, literally anything, somewhere. And this, I don't know if it is unique to the tech industry, but when you go to a tech conference, a lot of times those conferences try to have basic level talks, not just all, this new fancy framework, but also like, oh, and here's how you use map and filter on arrays. So whatever you want to talk about, whatever you've just learned, someone out there is interested in that. There may be a 10-year senior level C# developer who just doesn't know that much about JavaScript and wants to learn. And your talk could help them, even though you've only been doing JavaScript for a couple of months. So there are always people out there who want to hear what you have to talk about. So give talks. Do the work. Next section. So make sure your GitHub looks good, basically. You need to have projects under your belt to show people that you do know that you can do this. You can apply the concepts, right? So you can work on personal projects. You can work on volunteer projects. You can work on stuff for friends. Even if you just do an online tutorial, push that up to GitHub. That is impressive to have, in GitHub. So put all that stuff on GitHub. Do things for people that if your friend needs a website or something. And then I mentioned earlier that I made an LLC. And thinking back on that was probably a really wise decision. Because as soon as I was laid off, I started this LLC, and then I worked for that LLC until I started my internship in November. And I don't have a gap on my resume because of that. And that's not really why I did it. But thinking back on that, like that was a smart move, right? So what I was doing during that time was I was working on a project that I believed to be marketable. And because of that, I was like expensing stuff like my Udemy classes. I was also a very base level programmer, so I was learning. And I knew that, but I was also thinking that one day I could sell this product. So you can do this. You don't have to make money. You can also freelance for people if someone needs a website or something. If you know HTML, CSS, and JavaScript, you can write them a website. And you don't have to make money to expense stuff like monitors and laptops and things you might need, because it can be expensive. Studying tech can be expensive if you need new equipment. All right. So apply and interview. Apply everywhere. Apply to remote positions. If you need to be in a certain location, apply everywhere in your town. If you don't care where you work, apply everywhere. Okay, but what places are good for newbies? This is literally any place that will pay you to sit in front of a computer all day and code. I stole this from a friend of mine, but this is what he tells people, because this is very true. As soon as someone starts paying you, you're not having to do this in your spare time. You can make money off of it. You're going to get a lot better, a lot quicker as soon as you start a full-time job. If you're worried about things like, well, are they good at mentoring? Is it a good workplace for women? Like, these are real concerns. I would start asking around about the company with some of the connections that you've made. But again, like being paid to sit and code you're going to get so much better at it so much quicker if you can focus on that. And then you can move on to another job, hopefully pretty soon after that. All right. And then during the interview, always interview. Even if you don't think you're going to get the job, even if you think it's crazy, interview for Google. If they want to interview you, do it. Even if you don't think you're going to make it. In June of 2019, when I first got laid off, I interviewed for a contract position with Mozilla, and I knew I wasn't going to get it because I knew who the other person also interviewing for the position was, and she was amazing. And so I was like, well, I'm not going to get it, but it's probably good just for the experience. For the experience interviewing, you'll be better at the next interview. So every time you interview, you'll get better. And also, people will know you. So the hiring manager for that position, he I mean, they picked the other person, but he knew who I was. And then when I came in for the outreachy internship, I was probably, I don't know if that helped, but he knew me, and so it was easier for me to get started there. All right, and then I guess the last thing I wanted to show you was the resume I used to get my first job. Hopefully you can see this.
Yep,
Okay.
it's showing up.
All right. So I added this blurb at the top to, oh God, what have I done? To sort of explain myself, because it's like, yeah, I know it looks like I'm a chemical engineer, but don't worry, I'm not really a chemical engineer. I'm really a software developer. So I added a little blurb up at the top, but also the LLC that I started is called Risk Consulting, and I listed the project that I had been working on, and I worked on it for between June and November. What is that? 4 or 5 months, pretty much every day. So that's listed on there as one of the projects. Also, some freelance work that I did for a friend of mine at the same time is also listed on there. And then what else did I want to show you? Any of the courses I took, I listed under skills. And then at the bottom, I listed open source contributions. It was a little weird where to put this on the resume, but I wanted to make sure it was on here because this was good coding work that I did. And I didn't get paid for it, but it should be on here, right? So I think I have 2 more slides, but they don't really say anything. I don't know if I need to reshare. But so the 3 things were get connections, do the work, and apply an interview. And then that's it. That's all. That's my talk. Thank you.
Thank you, Kendall, for sharing all those great tips and resources. Like Kendall mentioned, Techlahoma is a great place for you to network, so please join us on Slack. Up next, we have Ryan Hoegg. I hope I'm saying that right. And he's going to be speaking to us about how we can understand what machine learning really is. Go ahead, Ryan.
Hi. Yeah, you said it right. So let me see. Let me get this shared. And boy, I appreciate both of your talks. My idea with this talk, so making sure you guys see it and get it up and running. My idea here is to share something with you about programming. So I've been programming. I've been through the journey that I guess John and Kendall have been through, although Kendall's is longer and went through MIT, so mine didn't go through that. I saw that on your resume. You didn't point it out, but mine didn't go there. But I started with programming, gosh, when I was very young, and there was a excitement, there's a aliveness, there's something about making computers do cool stuff that I've been able to hold on to for more than 20 years. So some of you may not be just starting your journey, some of you may be just starting your journeys, but you're always starting the rest of your journey. And it's not always exciting, especially when, because I got into reporting, I got into, I get paid full time right now. My job is called software integration. So I make programs work together behind the scenes. You can't even see my code. Other people's code is on the React front end or on the mobile app. My code's behind it, like making them work together. I still love it, but there's something, it could seem like you get into an area where making software is drudgery. It's a job. And this interest of mine, which I don't have it on this title, artificial intelligence, has sort of kept me excited or interested or looking at new things. It's kept my personal projects in the area of fun since 1994. So I'll tell you how old I am, I guess. So that's how long I've been interested in this. Now, this talk isn't about in artificial intelligence. I'm doing a talk about machine learning because artificial intelligence is too big. In fact, machine learning is too big for a 15-minute talk or a 10-minute talk. But the trouble with artificial intelligence and the trouble with machine learning is that we don't as humans, we're still kind of bad at understanding what intelligence is. So it's kind of hard to make our artificial version of it. But we're pretty good at breaking the problem down into smaller problems. So learning is one of the things humans do. And it's been a few decades, or about 4 decades, humans have been trying to figure out how to make computers think like we think. So we took like vision, for example. Computer vision is one kind of artificial intelligence area. This talk won't be about computer vision. There's natural language processing, so your Google Home and your Amazon Alexa can understand what you're saying. Somebody had to figure that out, right? So these are little jobs that brains do. And as humans, we've gone out and tried to find out more of them. So one of those areas that's got me I do all my fun projects in is machine learning. And some of it was at work. I actually did get paid for some of it, and I'll cover that in this talk a little bit. But a lot of it is not paid. Even though I'm a full-time software developer, like Kendall said, having somebody pay you to sit in front of a computer all day writing code is a great way to get better at code instead of having to squeeze it in between kids and snow shoveling and, you know, and I got a new puppy. I mean, there's a lot of things that can take away from your free time. So I did have a job where some of what we're going to cover this talk was actually paid work. And so what I want to share with you a little bit is how to tell when machine learning might be an appropriate thing to do, what it is, what kind of programs it are. It's really just a kind of computer program. It's a computer program that does a job. It's a computer program that learns while it's running. Think of it like that. So a lot of times you and I make a program, what we're trying to do is make the computer do something, okay? But if the something that we want the computer to do is to get better at a job, so for example, if your Google Home gets better at recognizing your voice, or if the badge system at your work gets better at facial recognition, or so there's all these little jobs computers can get better at without me programming them or without you changing the code. So how can that do that? It's not magic. The way the programs learn is they use memory, just like humans do. So machine learning is a kind of computer program you can make where you use data, which memory is, on a computer, memory is data that you write down in some kind of RAM or disk, right? That's all. But values of variables. Now, you're going to see there's a lot of them. If you're going to learn from experience, if you're going to learn from your memory, you need to have a lot of memory in order to get these programs to work. But we're getting better at it. They're getting more and more efficient. Nowhere near a 2-year-old kid. So, you know, like Google's and Facebook's ads that are telling you what you want to buy before you ever knew it, they're still not as good at it as a 2-year-old kid. But we're getting better, and it's kind of fun to learn how these things work. So we're looking at algorithms. So an algorithm is just a name for a kind of program. So maybe you're writing Python and I'm writing Go and someone else is writing JavaScript. We can all write the same algorithm in our different languages. So it's a job a program can do. And there's certain algorithms that work with memory that they write. Either they record it while they're running or we give it to it ahead of time. So you can make either one, right? You can make a program that keeps track of what happens and puts that in memory and learns from that. Or you can make a program where you give it a whole bunch of memory that you learned outside, like we do with that's how we recognize letters and stuff, OCR. You give it a whole bunch of examples of the letter A and say, that's a letter A, right? So there's more than one kind of memory you can give these algorithms. So the idea is learning how to make algorithms that get better at doing their job by using data rather than by us giving them instructions, right? So there's a few different kinds of learning algorithms I wanted to show you, and it won't all be slides because otherwise it would be kind of boring. They're all kind of fun. There are different kinds of fun. So supervised learning is what facial recognition and OCR are. It's where the humans already know all the right answers, right? And we're just trying to get the computer to get the right answers. Then there's unsupervised learning where we don't know the right answers and we want the computer to tell us. And then there's reinforcement learning where it's not even about answers, it's about actions. And I'll go through each one of those. So I'm going to briefly sort of introduce you to these different categories of machine learning algorithms because maybe one of those is really interesting to you. Well, one of them is really interesting to me, and I'll tell you that one at the end. But I like all of them. One of them takes my time the most. But maybe your interest is going to go in a certain direction. So to give away some of the secret, the one I got paid for is not my favorite. The one I got paid to do is called unsupervised learning, and I'll give that story when we get to it. So now, like Kendall, I think I heard in your story something really that clicked with me. When I first tried to learn AI, there was some advanced courses, and those advanced courses terrified me. And I probably took 10 more years before I finally learned neural networks, because the first time I learned it, I got overwhelmed with linear algebra and matrix math and differential calculus, which I hadn't learned yet. And I thought I was a pretty smart cookie with math, but apparently I wasn't ready yet. So don't worry, just like all computer programming, you can do 3D programming without knowing linear algebra, and you can do neural networks without knowing linear algebra, but it does help. I bring up neural networks because it's a tool that these different kinds of machine learning algorithms use. So you can think of it like in Python, there's a library called PyTorch, and it does neural networks. I'm going to show you a JavaScript one in a minute called Reinforce.js that uses it for one of their algorithms. So this is just like a little tool you can use in a bigger algorithm to make a part of a program change itself little by little every time you run it. So the program's got these numbers in there, and those numbers tell it, how likely is it that I should choose this instead of that? And after the next time you run it, maybe it changes its preferences a little bit. That's all. So that's the network part. We learned it from brains. We looked at how brains worked, and we tried to make computers do that. So that's what, when you hear the word neural network, it's an algorithm. It's an algorithm using a bunch of numbers and changing those numbers little by little over time so that the program does something different. That's all it is. So that, I want to take the mystery out of it. And either you're somebody who's really into math and you want to go make your own neural network, you can do that. Or maybe you're somebody who wants to just make a learning program, which I am. So then you're just going to go use a neural network. That you can use a library, and that's fine too. There's one called brain.js too, I think. That's not the one I'm using. So just want to take the mystery out of neural networks. Let me go through a little more on how these different methods work. Supervised learning is the oldest one, and it's probably the one you hear the most about. So you give in fact, the Twitter algorithm that recognizes faces and it's racist, it was a supervised learning algorithm, and it got racist because we gave it a whole bunch of pictures of white people and not so many pictures of black people, and it thinks white people are more likely to be a real face than black people. So that's what the AI ethics research going on now is trying to unpack is, if you're going to make a program learn from data, you better make the data good. Supervised learning is the kind of program that copies. It looks at what we do and tries to mimic us. It tries to memorize the way we categorize things and do it like us. The programs that can't tell dogs apart from blueberry muffins, those are supervised learning programs. This uses neural networks, and this is the one that's the most available. TensorFlow does this. It's not the only thing it does, but so you can find libraries to do supervised learning all over the place. So if you're interested in making something, for example, I was thinking of an example for freeCodeCamp one day. I could make a program that looks at pictures of all of you and detects people doing a dab. Like that's the kind of job you could do with supervised learning, right? Because I get 1,000 pictures, and all the ones that have a dab in them, I'm going to mark dab, and all the ones that don't have a dab in them, I'm going to say not dab, and then I'll see if the computer can remember how to tell them apart. And surprisingly, it does. I mean, you wouldn't want to write that algorithm to take the pixels apart and fix it, right? So that's what supervised learning is good for, if you want to investigate that. And I'm not going to teach it to you. And a lightning talk, my idea is to get you interested. Then you go take a Udemy course or something on the part that you like. So I'll tell you the one I got paid for is unsupervised learning. This was a company I was working on reporting and then what they call business intelligence, where you do a lot of reports and dashboards and graphs and stuff. And I took a statistics course, and this is where you look at data and you try to you make the computer try to figure out patterns in the data. So for us, it was like, do chicken fingers sell better in winter or summer? So we were looking at all the data of all the sales and we don't know. We're just going to ask it questions, right? And tell us where chicken fingers. The exact problem we did was tell us where chicken fingers sell the best. We don't even know, right? But it would group the sales for us. So it knows how to look at like if you look at a whole audience. Unsupervised learning is like this. If you look at an audience at a sports game and they do the wave, you can kind of see the wave. You can follow the pattern. That's statistical. There's some statistics to that. And unsupervised learning is a kind of machine learning algorithm that knows how to look at a bunch of data and find what's different. And it's really useful. So it's very stats oriented. If you're into math, you'd like it, but you can do it with R, for example. And this is the one that people pay for. So if you want to get a job, like an entry-level ML job would probably be like this, because that's a place where humans are bad at something and computers are really good at it. Go find patterns in data. Bank fraud would be like this too. So the one that I've been, my darling recently has been reinforcement learning, and I'm not getting paid for this, but it's a lot of fun. So what this is instead of trying to recognize things like what a DAB is or patterns in data, what you're trying to do is have a program actually do things. And then, but based on the results or the outcome of doing something, it's going to modify what it does. And for that, I wanted to show you guys an example in JavaScript. So I have it ready to go down here. Let's see. This is called reinforce.js. These are a few reinforcement learning algorithms, right? So I have one called grid world. So the idea is that there's a cell in here that's where the treasure is, kind of, and there's another cell in here where there's a poisonous snake or something. You can think of it like that. And you can look at, there's a method of reinforcement learning called dynamic programming, where it's going to keep going through each time you run it, it gets better and better at trying to find so I can turn it on so it just keeps running, trying to find the best way to get from the top left to the treasure without getting bitten by snakes. That's reinforcement learning. Yeah. So, oh boy, DAB project. I'm going to do the DAB project. I just saw that in the chat. So this is one of the many reinforcement learning algorithms. And there's a little better one. It's the same world, but this is called TD learning, and it has a little player in it. So in this case, you could like turn it on, and the player starts to explore. This is your program, right? Your program goes and explores its environment and tries to find the best way to get to the treasure. And it hasn't found the treasure yet. So I'm going to speed it up so you can kind of see what happens. Oh, now it found the treasure. And now it tries to get it. Every time it finds it, it starts over and runs again and runs again and runs again. And each time it updates its memory of the world to know what the best way through the path is. So this is called reinforcement learning. And these are the programs I've been playing with a lot recently. Oh, shoot. Is my screen going slow? I see a note in the Slack. I'm going to stop it, and I'll leave it up for a minute. So, all right, I heard that my video was delayed. So I will put a link to this in our Slack so that you all can try it out, these different algorithms. And if you guys could share that to the Twitch stream, then people could try them themselves. So anyway, this is that's reinforcement learning. It's the one I've been playing with a lot recently. So that's the lightning talk, so I can't go much further. I wanted to give you some resources. If you want to find me and a couple of other Techlahoma people who are into this, there are 2 channels in the Slack on Techlahoma. The AI Book Club is more for studying. The AI Battleground is more for my secret project. That's where that is. And then there's also an online machine learning course at fast.ai that's completely free. So I thought I'd give you those resources as well. So thanks for your attention. I hope I packed a lot into a short amount of time. And back to you, Alex.
Thank you, Ryan. That was really interesting, and I'm definitely gonna look at PyTorch and all the other libraries and resources that you shared with us. Up next, we have Fabio Dutra, and he will be talking to us about Scrum.
Okay, let me share my screen here. Can you all see my screen? Maybe?
Yes.
Okay, cool. All right. So my name is Fabio, as Alex mentioned, and today I'm going to talk about Scrum. So here is our agenda for today. I'm going to introduce myself a little bit more. I'm going to go into what is Scrum, when you should use it, when you shouldn't use it, some of the roles and responsibilities, the events, artifacts, and at the end I will share some interesting links and if you are interested in learning more about it, and answer some questions if you have any. So let's start. So who am I? I'm Fabio, as I mentioned before. I'm a software engineer for about 2 or 3 years now. I have certification Scrum.org, which is more specific in Scrum, and I see Agile. Since Scrum follows the Agile methodology, it's always good for us to keep our horizons broaden away. So I see Agile kind of helps with that. So what is Scrum? Scrum is a lightweight framework people, teams, and organizations generate value through adaptive solutions for complex problems, as you can see on the screen. And this this sentence I would say is loaded, so I'm going to expand it a little bit. Scrum is a framework. It's not a cookbook. It's not a step-by-step guide, and it's not also just a methodology or a list of values. It's a framework, so it has its rules, but it's not very clear on its implementation. Like I said, it's not a step-by-step guide. It generates value and not revenue, not shareholder happiness. It generates value, so a good product, through adaptive solutions, and that goes into the empirical process that Scrum has, which is we learn by doing it. The real true knowledge comes from experience. So we do it, we inspect it, and we adapt it to it. So that's where the adaptive solutions come from. And for complex problems, and here's it's very important because not every problem is complex. I kind of like this graph and the way that to categorize problems. There are a bunch of ways to actually classify problems. So complex are problems they are where the requirements are somewhat unclear and the certainty is somewhat unclear. So for example, if you want to do a payment service, if a client comes to you and say, I want a way to pay my bills, that is kind of complex because there are multiple ways of doing it. You don't know what exactly the client is wanting. You don't know exactly what bills they're wanting, and those requirements can change with time. So that's kind of a complex problem. There is also anarchy where you don't know anything. The client say, now I want everything blue, and now I want everything red, and then you have to keep redesigning your system a bunch of times. You don't know anything. The client doesn't know what they want, so that's anarchy. I don't know anybody that works in anarchy. That doesn't work in the real world. And then we have the simple problems. So for example, let's say you have a document company that provide online documents, and your client says, I want this period removed. This is a simple problem. The client just wants the period removed, and you just go there and erase the period, and then there you go. So that's a simple problem. Scrum really shines on complex problems. The complicated problems and the complex problems, they kind of go back and forth. That barrier is not very clear, but just keep in mind that you need complex problems for really Scrum to give value. So Scrum has three roles. The very first one is just the product owner, which is just one person, not a committee, not one person and a helper, not some kind of board. It's just one person that has its role and responsibilities. We have the Scrum Master, which is also one person. And then if you're not a product owner and you're not a Scrum Master, then you are in the development team. So testers, technical writers, business analysts, they are all considered to be in the development team. In the 2017 version of the Scrum Guide, the recommended size of the development team was between 3 to 9 people. In the 2020 version that was released last month, they said enough people. But enough people to do what? It needs to be enough people that you can generate value, but not too many people. That coordination between them kind of becomes a hassle, becomes a barrier instead of becoming something positive. So that's why the recommendation from 3 to 9 people was there in the 2017 version. But people got too attached to the numbers of 3 to 9. There were some people that says, oh, more than 9 people is not, it's illegal on Scrum. So they took that out and say it's enough people. If you think you have enough people to generate value, but not too many people, that coordination becomes a hassle. Then there you go. You have a good size of the development team. So I'm going to start to explaining what the product owner's responsibility is. So the product owner, her or his responsibility is to maximize the value of the work done by the development team. And how he does that is by adding a clear description to the backlog item. So a backlog item is just basically a case, a ticket, a to do checklist or something like that. It's just one thing that needs to be done in the product. We're gonna call that product backlog item. So we need to add a description in a way that the development team knows a little bit what the product owner means when he wants that. When he say I want to add a payment service, you might not know all the details, but from the description you can kind of understand a little bit what the direction this is going to. Is going to add the business value. It can be numbers, usually are numbers, but it can be fruits or objects or anything that makes sense and is transparent to everybody how the product owner is organizing the business value to it. And it will add an order, and this is really important. The product owner will order the product backlog items in a way that the value of the work at the top will be the best. So if the payment service is something that all the clients want, they're probably going to go on the top. And if they want the remove, which is something that sometimes complex solutions have, but if they want something smaller, then probably goes in the bottom. So and that order is solely to the criteria of the product owner. So changes from product owner to product owner, from company to company. The Scrum Master, which is the other role, um, is the person that knows Scrum the most. It, this person it's usually called a servant leader. There is no hierarchy between any of the people in the group. So the Scrum Master is there to help everybody else in the company with Scrum. So we will help the Scrum team and we'll help the organization, we'll help the PO in doing their work better. So if they have anything going that it's kind of following out on the Scrum or it's not having the best value to the events or artifacts or anything like that, the Scrum Master can go there and remove those impediments and help them understand the goals of meetings and things like that. And it can even help the development team do the work or help the PO maximizing the value. Scrum Master is there to serve the team and the organization with Scrum. The development team, which is basically everybody else, they ensure the quality of the product. They are the people that do the work. So they get one to do item and get each one done. Working increment that will be released possibly in the future. They also plan and commit to the sprint goal, which I'm going to talk a little bit more later. And this is really important because they hold each other accountable for the quality of the product. So there are no managers there. Scrum is really about self-managing teams. So the team will have to hold each other accountable, will decide how to do the work, will be the ones that decide what they want to do next. These things are all responsibilities of the development team, and they coordinate a lot so everybody's on the same page. And to help that coordination, Scrum has 5 events, 5 formal events. The daily Scrum, the sprint review, sprint retrospective, sprint planning, and the sprint. As you may have noticed, I said the word sprint a lot. So what in the heck is a sprint? A sprint is a container for all the other events. It's just a period from 1 to 4 weeks that well all the work will be done. They will have a goal in mind that the team will do something that they want to do. They will decide a goal and they try to do as best as possible. And it is 1 to 4 weeks because in the business world, 1 to 4 weeks to kind of generate that innovation is not a long time. It's a risk that we can take. So if you take 4 weeks, for example, trying to generate a new AI program, and you say, okay, this is a promising thing, and that's good. But if you say this is worthless for us, then that's fine too. It's like it's a risk that you took and you might lose, but it's just 4 weeks. So sprint works as a risk control mechanism in Scrum. One important thing that I would like to mention in the sprint is that the sprint quality does not decrease throughout the sprint. Quality is the very first thing, is the most important thing that everybody is looking for, is the quality. And a sprint starts when the previous one ends. So if you have sprints of 3 weeks, after those 3 weeks, you're gonna say, okay, what do you have now? There is no, oh, we need a little bit more time, or let's just do this really, really rushed with no quality because the sprint is ending. There is nothing like that. Sprint starts when the next one ends, and quality does not decrease. So the daily Scrum, because the development team needs coordination and everybody needs to be on the same page all the time, the daily Scrum happens every 24 hours for the development team only. These are the only people required to be in there. The daily Scrum is a meeting where the development team will inspect what everybody did on the last 24 hours and make sure that they have the sprint goal in mind and say, okay, do we need to adapt? Do we need to try new things? Do we find any new barriers that need to be addressed? So the daily Scrum is a meeting for the development team to to keep everybody on the same page, to kind of know what they're doing, how they're doing, and everybody to help that coordination that is required. The maximum duration of a daily Scrum is 15 minutes. And that is because usually when you have a meeting without a maximum duration, they can go long and they go into like weird unrelated rabbit holes that do not add any value to the coordination of the development team. So the maximum duration is 15 minutes, no matter what the size of the sprint is, which is not the case, for example, of the sprint review. The sprint review is a maximum of 4 hours to a 4 week sprint. It usually this maximum duration is shorter when the sprint is shorter, proportional to the size of the sprint. A sprint review is where the Scrum team, the PO, Scrum Master, development team, and key stakeholders, it can be users, it can be support, it can be whoever the product owner thinks can have good input in the increment, where everybody gets together and inspect what they've done in the last sprint. So they will see what the result of the sprint was, and then they will say, okay, we now have one payment, for example, one payment way of like we implemented PayPal. Now let's try to implement Venmo or something. So they can inspect the implementation of one thing, and they can determine future adaptations to that we deliver more value to our customers, deliver more value to our support group or users or anything like that. So the sprint review works like that. The sprint retrospective is a meeting for the Scrum team to inspect itself. So inspect how people communicated, how people coordinated, what process do we have, what tools do we use, and it's only for the Scrum team. There are no managers, no auditors, or anything like that. The sprint retrospective is just for the Scrum team. It's up to 3 hours through a 4 week sprint. It's shorter if the sprint is shorter, so proportional like the other one. The sprint planning is where everything starts. This is where the Scrum team will decide what they will do next sprint. They will also decide what the goal of the sprint is going to be. And this is attended by the Scrum team, but outside people can be invited if they have any kind of special knowledge that the Scrum team requires so that they can plan their sprint better. Um, this is, like I said, up to 8 hours to a 4 week sprint. If the sprint is shorter, it's usually shorter too. Sprint has like Scrum has three artifacts that are really important, and I mentioned those terms before, and I'm going to go into a deeper on them a little bit. So the very first one is product backlog, and the product backlog, I mentioned what a product backlog item is. So the product backlog items, they live in the product backlog. Product backlog is everything that needs or is wanted to be done in the product. Everything that a team has a to-do item goes into the product backlog. It's ordered by the product owner, as I mentioned, and it's committed to the product goal. And the product goal is a future state of everybody's happy 100% with the value that is being delivered by the product, where the maximum value delivered is being delivered to the users, and the product works great. Is, oh my god, this is nice. This is the product goal. So the product backlog always has the product goal in mind, is committed to it. The sprint backlog is the junction between the sprint goal, which is why we're doing what we're doing, and a plan, an actionable plan on how to do the things that we want to do. The sprint backlog is managed by the developers, and it's for the developers only. They know how to transform a to-do item into a done working increment. So that the sprint backlog is for the developers or the development team. Its commitment is to the sprint goal, which is a sprint goal is just a single objective for the entire sprint. It's created during sprint planning with everybody there, and every time the sprint backlog will be moved, always thinking what's the best for the sprint goal. The last artifact I'm going to talk about is the increment. And the increment is just a concrete stepping stone towards the product goal. If we were building a house, the increment was going to be a brick. That one brick that goes in there, that's the increment. It's done by the development team and inspected on the sprint review, as I said. And its commitment is just the definition of done. And this term is really important in Scrum. Definition of done is basically a common understanding from everybody involved in the product, user, support, the Scrum team, PO, Scrum Master, what done means. And you can say, oh, done means I did the code. But it can be also done means I did the code and now I did security checks and now I did unit tests. And that kind of changes of adding security checks and adding unit tests, it is inspected and adapted during sprint retrospective. This is where the team will say, our definition of done, what done means, is that the best possible or can we make it better? So this is where like the definition of done is really, really important because everybody shares what done means. When I say something is done, everybody knows what that means. And that's why sprint retrospective is so important. If you want to learn more about it, I know I kind of rushed you through all the terms. If you want to learn more about it, I would start by the Scrum Guide. There's a new version that was released last month, as I said. Um, the Scrum Guide has everything I said in much more detail, all the responsibilities, events, roles, things to aim for, definitions of Scrum and things like that. So it's a really good resource and it's not too long. So it's I would say it's a kind of a light read. It's not very difficult to read that. Then we have the two certification entities, which is the Scrum.org and Scrum Alliances. They do give certifications in classes and things, and they have huge forums with questions from going from like beginning level of Scrum to very advanced questions to day-to-day things in Scrum. What's the best way? People opinion, things like that. And I'll also mention that the Techlahoma Slack has an agile channel that we usually answer. So yeah, if you want to learn more about Scrum, I would advise any of these links is really, really helpful.